Greetings, ladies and gents. Welcome back at St. Mike Maths and Science Club. Today we are starting with the annuities. Now, remember, we are still under our financial maths section. So today we are going to to introduce the annuities, and then of course this part is you only find it in grade 12. We did not do this in grade 11. So by definition, what is an annuity? Now, an annuity by definition is a series of regular fixed payments made over equal time interval. So the word, equal time interval, it could mean it means it could be monthly, yearly, semi-annually, or even every quarter in this case. So again, remember we said the regular fixed amount. Again, it must be a fixed amount, so it can be 500 every every year or every month. So in simple words, an annuity is either when you decide to save or receive the same amount regularly, like every month for a specific time period. So it can be the money that you save, like monthly deposits, or the money that you receive, like like pensions payouts, or the loan payments. So we have two types of annuities. We have what we call, now again, an annuity. Let me just write the definition for that. So an annuity is at the regular fixed payment. So the regular fixed payments. Now we have two types of annuities. We have what we call the future value annuity, and what is known as of course the present value annuity. So we have two types of annuities. We have the future value annuity and the present value annuity. Now in today's lesson, we're going to focus on the future value annuity. We're going to introduce, of course, the present value annuity as time progresses. Now, but in this lesson, we're going to to do the future value annuity. So again, the future. So we're going to focus on the future value. So that will be the future value annuity. Now again, what is a future value annuity? Now by definition, a future value annuity is the total value of regular fixed payments made over time, including interest, at a specific future date. So in simple words, I would say it's simply it's how much money you will have in the future if you save or invest the same amount regularly, and of course your money earns interest every time. So it basically answer the question, if let's say you save 500 every month for 2 years, so the future value annuity is the total amount you will have at the end, including of course the interest that each amount grows, or rather I should say that the interest that grows each month. I should rather put it in that way. So again, the future value is the total amount, in this case is the total value, of course, of regular fixed payments over time at a specific future date. Now suppose an example of that. Now suppose we're making an investment, let's say for 4 years. Now of course, now suppose we start at the end of the first year. Now let's suppose it's yearly. So of course that would be T1, so that would be T2, so that would be of course our T3, and that would be T4 right there. Now suppose we're making an investment of 500 every year. Now suppose we start at the end of the first year. Of course at the beginning, or actually at the end of the first year. So of course in this case it will be at T1. So in this case, now suppose we invest 500. So of course at T2, of course at the end of the first of the first, in this case, we would invest another 500. Now remember, at the end of the first year, I think actually I'm kind of mixing this. So at the end of the of the first year, we would invest 500, and at the end of the second year, in this case, we would invest another 500. So of course at T3 again would invest another one, so it would be 500, and also there it would be another 500. So in this case, so the future value annuity would be the total value of all of these payments. Of course, at let's say at T4. Now suppose they say calculate the future value annuity, of course, of all of these payments. It after 4 years. Now suppose they say they gave us an interest of, let's say, 13% per annum compounded, let's say annually, in this case yearly. So that would be 13% per annum compounded annually. So in this case, so what you need to note is that of course, this, if they say calculate the future value annuity of all of these payments, of course after 4 years, but what you notice that this payment here, it would it will not actually earn in any interest, I should rather say, but this one, however, here it would earn interest for 1 year, because it was in the account, or in this case for 1 year, right? In this one here, it would be in the account for 2 years, and that one there, it would be in the account for 3 years. Now of course, now remember on our last session that we had, on the first video that we made, of course we were doing, I think it's the second actually, where we were practicing what we did in grade 11. I specifically mentioned that you cannot, of course, take this 500 and that and say I have 400. Of course, I have 2,000 after 4 years. Now remember why you cannot do that. The reason would be, now you, of course, we know that 500 at T1 in this case is not the same as 500 at T4 or at T5 in this case after 5 years. Why? Because we know that when you invest in when you invest money, we know that money grows, right, as time progresses. So 500 now is not worth 500 let's say after 5 years, because money, of course, it earns interest, so right, as time goes. So you can only add or subtract money unless if you know how much it is worth at the same time. Now remember, in this case we chose of course T4. Because they say now they say we must calculate the future value of all of these payments, including the interest, right? So the future value, of course, of this of all of these payments, it would be, now that would be VF. So that's the future value. So in this case, so that one, the first one there, it would earn no interest, so it would be just that 500 plus, of course, the one that was in the account for 1 year. So that would be that 500 there. So that would be 500 1 plus, but that would earn interest for 1 year, right? So that would be 0.13, but for 1 year, plus, of course, it would be that one there. So that would be 500 1 plus 0.13, but in this case for 2 years, plus, of course, the one there. So in this case, that would be that 500 1 plus 0.13 for 3 years. So in this case, the future value annuity would be when you sum all of this. Now if you can put all of those values on your calculator, you would be able to get an amount of 2,424 rand and also 90 cents. So that would be the future value annuity of all of those payments after 4 years. Now you can see why we said you cannot take this 500 and that and add them up together and say I have 2,000, because we know that money, of course, in this case, it earns interest as time progresses. As you can see that the solution that we got in this case, it was 2,424 rand. So in this case, that 424 would be the interest that that was earned as time progressed. Now suppose again, let's just take another example. Now suppose again we're making an investment. So now suppose again we were to make it at the end of the first month. So in this case, this would be T1 at the end of the first. This would be a T2 at the end of the second. That would be a T3 at T4, and let's say T5, and let's just end at T6. Now suppose we were to make it the first payment again at the end of the first month, of the first year rather. Now, so of course at T1 in this case, this is where we would actually make the first payment, right? So this would be, suppose it was 600, so this would be where we invest our 600. And also at T2, now remember, it must be a fixed amount, I should rather say. It mustn't change. So it must be a regular fixed amount, so it must be the same amount that I invest every year in this case. So that would be another 600, and that would be another 600. Of course, as you can see, so that first one there, it would earn no interest, but that one there, it would earn interest for 1 year, and also that one there, it can earn it would earn interest for 2 years, and so on and so forth, until of course we get to the first one. Now what I need you to note, ladies and gents, is the relationship between these two. Now remember, of course we were summing, of course, the 5 payments, right? We made 5 payments, but you can notice about that first payment there that we made, it was in the account in this case for how many years? So it was in the account for, in this case, that would be 1, 2, for 3 years. So you can see that the last payment there, it was in the account for 3 years, even though we made 4 payments. So in the same manner, this first payment here, it would be in the account in this case for 5 years. So remember that one there, it was in the account for 1, so that would be for 2 years. So this would be for 3, and that would be for 4, and that would be for 5 years. Now the future value, of course, of this would be when I add all of these payments, including the interest, right? So this would be future value equals to, so the first one, which is just the 600, plus the second, so this would be 600, 1 plus 0. Now suppose I didn't actually add the interest in this case. Now suppose they say it's 15% per annum, compounded annually again. Now there's a reason I'm actually starting at the end of the first period in this case. Now we're gonna discuss that when I introduce the future value annuity formula at the end. So again, of course, this one here, this amount there would earn an interest for 1 year. So that would be 0.1, that's 1.5. So we said 15, right, for 1 year, plus 3, of course, that's actually 600, 1 plus 0.15. So this would be for 2. Again, we would have another one, 1 plus 0.15. In this case, that would be for 3, and then plus there. Just gonna add all of them. So it would be 600, 1 plus 0.15 for 4, plus the last one in this case, which was in the account for 5 years. So that would be 1 plus 0.15, but in this case for 5 years. So if you put all of those values on your calculator, you would get a value of 5,000. So that would be 5,252, and of course, and 24 cents. So that would be the future value annuity of all of those payments, of course, after 6 years, and their interest, of course, the interest that they earn as time progresses. So that would be the future value of all of those payments. And also what I need you to note is that the last payment that we make is made at the at the end of the investment plan. So if it is an investment. Now what we're going to do is that we're going to take one last example before we do questions that are similar to that which we find in the exam. So we cannot do one question So now again, suppose we're making another investment in this case. Now let's say for this one, let's just say after 50 years. Now again, let's say we make it at the end of the first year. So this would be T50. So that one there, it would be a T49, of course, and so forth. And also that one, it will be a T2, and also the other ones which are in between. Of course, now suppose we were making yearly deposits of 300. So a T1 in this case, so this is where we would make our first investment. In the T2 we will do the same in until that last payment there, and also the one at T49. So we would make another investment there. Now suppose they say they offer us an interest of let's say 24 percent per annum compounded annually. I'm just gonna stick to annually because it kind of makes our calculation easy in this case, but it doesn't have to be yearly. It can be monthly, semi-annually, or even quarterly. So I'm just doing this so that it makes our example in this case easy to understand. So in this case, so again, if I were to calculate the future value annuity for that, now remember that payment there at T50, it will earn no interest, right? But that one there, it will earn an interest for 1 year, and all of those, of course, of all of those payments that we made in between, until of course we get to this point. So that would be and then it would be that one there. Now remember, the first payment that we made, it would be in the account for 49 years. Remember, the relationship doesn't change, and of course that one, the one we made at T2, it would be in the account for 48 years. Now if they say they want the future value annuity of this, of course I'm sure some of you are saying, isn't there better question that you can do to challenge us? Now suppose, now again, to calculate the future value of that, it would be future value, of course, which is denoted by that, would be equal to the first, which is just a 300, plus of course that 300 there, which was in the account for 1 year. So that would be 1 plus 0.24. We said it's 24, right? So that was actually 24% per annum compounded annually. So that would be plus, so that would be in the account for 1 year. And of course the one at T2 in this case, it would be in the account, of course, for 48, of course, for 48 years. So that would be plus, and also the other ones are in between, plus the one there. So that one would be 300, 1 plus 0.24, but it was in the account for 48 years. So that would be 48 plus the one, of course, we made at T1, which would be 300, 1 plus 0.24, which was in the account in this case for 49. That would be for 49 there. Now on our of course first practice that we did on the grade 11 work, I kind of came with a strange value when I think it was on the timeline question. I made an error for the first time, and I got an answer that shocked me. And I did that for the second time. I actually did it 3 times to verify my answer. Now if you don't mind, ladies and gents, can you just try to verify the value that I'm about to write now, that I'm about to write down there, because it's actually another strange value, if you ask me. So if we put all of that in our calculator until at T49, you'd get a value of 58,611,700 and 93, and of course in 20, that's 27 cents. So that's the value that I got. It's a strange value. So if you don't mind, can you just pause and put those values to verify the answer. Now, what you will notice is that you can't put all of those values. Our calculators in this case, they gave us a limitation to a certain number of values that we can actually plug in. Now the question is, what did I do? How did I get to that solution there? Now, ladies and gentlemen, let me introduce you to what is known as the future value annuity formula. Now, what does it say? It simply says uh, FV, which is future value, is equals to X, 1 plus interest, so that to the power n minus a 1, and all of that is divided by I. Now, which is which? Now, X stands for the regular fixed payments. So that's the regular fixed payment. So that's the amount that, of course, that we made every month, right? So it must be fixed. So in this case, it was the 300. And N in this case stands for the number of payments that we made. So in this case, that's the number of payments. And of course, I in this case, it stands for the interest rate. So of course, what I did, I just plugged those values. Of course, the first the value of X in this case was 300. So that was 300 there. So that's 1 plus 0.24. But in this case, how many payments did we make? We made, of course, 50 payments minus 1. Divide all of that by 0.24. Now the reason why I said I need you to note that is because there's actually a proof for this formula, but I'm not gonna actually include it in this video because I don't want to make it long. I wouldn't want you to to fall asleep while watching it. So in this case, what I'm gonna do is that I'm gonna do it separately, but it's not actually examinable. So if you, of course, you don't want to know it, I'm just gonna do it for I'm actually gonna do it for those who who are wondering where this or where this formula comes from. So in this case, we're gonna get the same value, which is 58,611,793 and of course 27 cents. So that's the value that you're gonna get when you plug there. Now, one thing that I need you to note about this formula. So the most important thing that you need to note is that built into this formula is the idea that the first payment is made at the end of the first time period. In this case, we made it at the end of the first year, right? So the first payment, so that's the first payment, or let me just say built into this formula is the assumption is the idea that that the first time period passes and the first payment is made, and the first payment, I hope that's visible, is made. So so in this case, of course, the one time period must pass before the first before the first payment is made. So in this case, it is made at the end of the first period. So in this case, it was at the end, of course, of the first year. And also the other thing that you need to note is that the last payment is made on the last day of your investment plan. So the last payment is made on the last day. So that's what's built into this formula. So what's built in this into this formula is these two ideas. But now some of you might be wondering, now what happens if you decide to make in an investment immediately there at at T0, or what happens if if you were to miss the few, let's say, few payments at the end, what would happen then? Now that's what we are actually gonna do in our actually next video, not the one that we're gonna do next, because the one that we're gonna do next is that we're gonna do practice questions to get used to this idea of the future value annuity. And after that video, that's where we will look at what happens now if if you miss the last few payments, or what happens if you decide to start immediately. In this case, it will be at T0. So that will be of course for the session of today. So this is what I wanted us to cover. I wanted to introduce this future value annuity, and also of course the conditions that this formula works based on. So on the other video that we'll do, in this case we'll look at what happens if you decide to pay immediately, or what happens if you miss the last few payments. So if you haven't subscribed, please do so, so that when this lesson comes up, you don't miss anything. Now, if of course if this video helped you, be sure to like. If you have any questions that you would like to ask, you can always throw that on the comment section. Otherwise, this is it from me. Until next time, when of course when we meet to do the practice questions. So that's the video that's we're gonna do next. Sharp sharp.